Good morning, scholars, and welcome to another edition of Chemistry with Kirby. In this video, we're going to be doing a lab about how soap works that reviews a lot of the things we've been learning about polar and nonpolar molecules and intermolecular forces. Let's get started. So to start off, we're going to fill a bottle or container about 2/3 of the way full with water. I've got mine right here all ready to go. And then we're going to add approximately 3 to 5 tablespoons of vegetable oil or cooking oil, depending on how big your container is. So if you're using a basic water bottle like this, probably about 3 tablespoons is enough. If you're using something larger, like a gallon or 2-gallon kind of container, like a milk jug, you might want to add more, like 5 or 6, just to make sure you've got enough in there to get you going. So now I've got my oil added with my water, and I've got it in my container here with the lid on tight. And you'll see that the oil floats on top of the water. This is because oil is really nonpolar and it's less dense than water, and things that are polar and not nonpolar don't really like to mix together. Water is super polar. And so what we'll see is that when we shake it up, we want to watch what happens after we shake. So we're going to give it a good shake now. And then let it sit. So as you're letting your oil and water mixture sit after you just did the big shake, you'll see that the oil rises up to the top while the water settles back down to the bottom. Sorry, there's a little glare here, so it's a little bit hard to see, but I've got all my oil up top right up here and all my water down right here. Maybe this will help. And what you'll see is that the oil is nonpolar, meaning that there isn't really a sense of partial charge in that molecule, while water is really, really polar. Oxygen in water pulls the electrons towards itself, giving it a partial negative charge, and the hydrogens in water become partially positive charge. And because oil is nonpolar and water is polar, this means that they don't really like to interact with each other, so they kind of settle off. This is why when you try to wash dishes without using any soap, if you've washed something that's really oily, it's not going to work because the water and the oil don't really mix with each other. So water just doesn't wash oil away all by itself. You need something that can get the oil and water to mix together. And that's where we get into talking about soap today. So I want you to make a prediction right now. How many drops of soap do you think will be needed to get all the oil to mix in with the water? And this would be your hypothesis. So write that number down now. Great. So now we're going to begin experimenting. We're going to add 1 drop of soap into the bottle, close up the lid, give it a good shake for at least 10 seconds, and then set the bottle down and let it settle for a minute. What we want to observe is, as it settles, is all the oil dissolving and disappearing into the water, making one big cloudy mixture, or is there still oil settling on top? So after just 1 drop of soap, I'm starting to see that the water mixture is becoming a lot more cloudy, but I still have some oil on the top. So I'm going to add another drop of soap and repeat. You can do the same thing. And what you're trying to do is just keep track of how many drops of soap do you need to use to get that oil to mix in with the water. So I'm at about 16 drops of soap right now in my experiment, and it's looking like just about all the yellow oil is really gone from the top of my bottle. So I'm going to say that at this point, I've pretty much got all the oil mixed in and I'm going to be done. So it took me 16 drops of soap. Now you might be thinking that doesn't seem like very much soap for all that oil that was in the bottle. And the truth is, like, it's really not. But that's because soap is really, really awesome at getting oil and water to mix together. And we're going to talk about why. So what does soap do? So a soap molecule basically has 2 main parts. It has this long chain of carbon and hydrogen atoms together that are pretty nonpolar. And so that is really good for sticking to things like oil and grease and stuff like that that's really nonpolar. And then the other part of soap is this polar end, this head that can stick to water and anything else that's polar. So soap is really good because it has these polar and nonpolar parts, so it can bind to anything that it wants in order to kind of like get it washed away. So what happens mostly when you're washing your hands or when you're washing dishes or anything like that is that the soap it forms this structure called a micelle, where in this case, like the oil particles at the center and all of these long hydrocarbon nonpolar chains and the soap molecules get they form this like circle all around the oil particles. And so that nonpolar part is on the inside of this micelle structure. And then the polar, the hydrophilic, the water-loving part of the soap is around the outside. So when you're washing your hands or you're washing dishes, those nonpolar parts of the soap wrap those oil particles, those germs, anything else that's nonpolar, they wrap it up in the center with all these nonpolar hydrocarbon, hydrophobic, afraid of water tails. And then the polar, those little circled polar heads, these hydrophilic things that like the water, are around the outside. So when you lather up your hands or you're lathering up your dishes, you're wrapping up all those oil and grease and germs in this center micelle, and then the outside is the water part. And so those hydrophilic polar ends of the soap are going to run away with the water. So you wash your hands with all this soap, you build up a lather, you get all those particles trapped up inside the soap in this micelle by their nonpolar tails, and then their polar heads, this hydrophilic water-loving part of the soap, runs off and carries them away in the water down the drain. So now you know a little bit about how soap works. Great job! Thanks for joining us. If you're a junior in my chemistry class, you should be taking a look at that document on Google Classroom, Unit 6 Summary Lab, and finishing up. If you're just a person who's watching for fun, thanks for joining us. Have a great day.